That familiar pang of frustration, trying to sort out a simple payment.
Oh, yeah.
Bouncing between online wallets, banks, all those third-party apps. It's a common modern headache, right?
Definitely.
Well, what if I told you there's a game-changing technology that's fundamentally rethinking how we handle transactions, making them simpler, safer, and more transparent? We're diving into the world of blockchain.
That's right. And for this deep dive, we've gathered a really fascinating stack of sources. They're designed to give you a clear, sort of concise understanding of blockchain.
Okay.
Our mission isn't just to explain what it is, though that's important. It's really to uncover how this, revolutionary technology works, why it matters so much.
Right.
And where it's actually already being used to solve some incredibly complex real-world problems.
And you can rest assured you're getting the express lane here. We're aiming to make you well-informed about a topic that, let's be honest, often feels incredibly dense. We'll dig into some surprising facts, connect the dots in maybe unexpected ways, and hopefully inject just enough humor to keep you hooked. I promise.
Sounds good.
So let's kind of unpack this with a scenario. Something most of us can relate to. It's straight from our sources. Imagine 4 friends, Jack, Ted, Sam, and Phil out for dinner.
Okay.
Jack generously covers the bill, right? Everyone agrees to send him their share. So the next day, Phil sends his portion to Jack, using a traditional online money transfer. And it sails through. Easy.
Yep, happens all the time.
But then when Ted and Sam tried to do the exact same thing, their transactions just fail.
Yeah.
Mysteriously.
Yeah, it's a classic modern-day hiccup, isn't it? Our sources point to several common reasons behind these kinds of traditional bank transaction failures.
Like what?
Well, it could be technical glitches on the bank's end. Maybe a hacked account was flagged.
Right.
Or even something as mundane as just hitting a daily transfer limit.
Oh, yeah, those limits.
And let's not forget those often hidden transfer fees that kind of chip away at what you're sending. These vulnerabilities, these points of failure and friction, they fundamentally paved the way. They showed the need for a new, more resilient kind of financial system.
Okay, so if traditional systems are prone to these sorts of trust issues and, technical failures, what became the answer? What addresses these frustrating problems? Our sources point directly to the concept of cryptocurrency. And here's the crucial part. Cryptocurrencies are built on and powered by blockchain technology.
Exactly. And what's truly transformative about cryptocurrencies that run on blockchain is how they fundamentally tackle those trust issues.
How so?
Well, first, they become virtually immune to counterfeiting. Second, they operate without needing a central authority like a bank.
So fewer points of failure.
Precisely. And third, they're secured by incredibly strong, really complex encryption algorithms.
Yeah.
Now, while there are thousands of cryptocurrencies out there now, Litecoin, Ethereum, Zcash, Bitcoin really stands as the pioneer, the dominant force that proved this new way of doing things wasn't just possible, but actually incredibly robust.
Okay, now let's take our friends back to that dinner scenario, but let's switch it up. This time, they're dealing in Bitcoins.
Okay.
Phil, Ted, and Sam are each sending Jack 2 Bitcoins. And just for context, let's imagine Phil, Ted, and Sam each started with 3 Bitcoins and Jack had 5.
Got it. So when Phil sends those 2 Bitcoins to Jack, that transaction doesn't just disappear into the digital ether.
No.
No. Instead, a permanent record of it gets created, and it's inscribed into something we call a block.
A block. Okay.
Right. This block holds all the transaction details, who sent what to whom, and critically, it updates the number of Bitcoins each friend now owns. So after Phil's transaction, Jack has 7 Bitcoins, right? And Phil is down to 1.
Okay, that makes sense. And as Sam and Ted send their 2 Bitcoins each to Jack, what happens then? Do they just make more blocks?
Exactly. Each of their transactions also creates a new block, recording their specific details, and the newly updated Bitcoin counts for everyone involved.
Okay.
Now, here's where the real genius of blockchain comes in. These new blocks aren't just floating around randomly. They are cryptographically linked to the previous blocks.
Linked? How?
Think of it like a digital chain. Each new link, each new block, is forever attached to the one before it. It references the state before the transaction. This ensures the integrity of the whole sequence. This interconnected sequence, this growing chain of records or blocks, that's what we call a ledger.
Ah, the ledger. And what's really revolutionary about this ledger saying is that it isn't kept secret by one person or one bank.
Precisely. It's shared among all the friends in this scenario.
Right.
Or in the real world, across the entire network.
So everyone has a copy.
Yes. This shared, transparent, and distributed record is the absolute essence of a public distributed ledger. It forms the very foundation of blockchain technology itself.
Wow. Okay, so this transparency and distribution, what does that mean for security? Like stopping mistakes or fraud?
That's a great question, and it gets to the core of blockchain's power. Let's use our friends again. Imagine Phil, who now only has 1 Bitcoin left, tries to be sneaky and send 2 more to Jack.
Right, he doesn't have them.
Exactly. What happens? Well, the transaction simply won't go through. It gets rejected.
Why?
Because every single one of his friends, every node on the network, has a copy of that shared ledger. And that ledger clearly shows Phil only has 1 Bitcoin left. They would instantly flag that transaction attempt as invalid.
Ah, so the network itself polices the rules.
Correct. It demonstrates how data, once it's recorded on the blockchain, simply cannot be altered without consensus. A hacker can't just go in and change the data because every user holds a copy of the history. Plus, the information within those blocks is locked down by highly complex encryption. It's incredibly resistant to tampering.
So it's a system built on, like, verifiable truth, not just blind trust in some middleman.
You got it. It shifts trust from a central entity to the network and the cryptography itself.
That friends ledger analogy really does a great job illustrating those core ideas: shared, immutable, transparent. But okay, to really grasp how that digital security and decentralized trust work in, say, an actual Bitcoin transaction, we probably need to peel back another layer, right?
We do.
How does this function at a more technical level?
Okay, so what's fascinating here is the digital identity system involved. Every user in the Bitcoin network essentially has 2 unique cryptographic keys.
Keys, like literal keys.
Well, digital keys. First, you have a public key. Think of this like your email address or your home address is this address people use to send things to you. Everyone can know it.
Okay, public address. Got it.
Then there's your private key. This is the crucial one. It's a unique address, or rather a secret code that only you know. That's like your password, or maybe the key to your personal digital vault. You never share this.
Private key. Super secret. Okay, so how do these keys work when Phil sends Bitcoin?
Right. So when Phil wants to send those Bitcoins, he takes the transaction, details the amount, his own wallet address, his public key, and Jack's wallet address, Jack's public key. And he passes all that information through something called a hashing algorithm.
Whoa, okay, hashing algorithm. Sounds complex.
It is, but think of it like this. It's a super advanced digital blender. It takes all that input information, no matter how big or small, and creates a unique, fixed-size digital fingerprint out of it.
A fingerprint?
Yeah, it's sometimes called a hash. It's like taking a whole book and distilling it down to a single unique barcode that represents only that book. Change one word in the book, you get a totally different barcode.
Okay, unique digital fingerprint. Got it. Then what?
Then this digital fingerprint, along with the transaction details, gets encrypted. They use strong encryption algorithms, but here's the key part. It's encrypted using Phil's private key.
Ah, the secret one.
Exactly. This step essentially digitally signs the transaction. It's mathematical proof that the transaction genuinely came from Phil because only he has his private key and that it hasn't been tampered with since he signed it.
Okay, so it's signed and verified as coming from Phil.
Right. Then the output of this signed transaction is broadcast across the network, and it's often secured using Jack's public key. This means only Jack, using his private key, can fully decrypt and access the message or the value being sent, ensuring privacy and security during transit.
Wow.
And different cryptocurrencies might use different hashing algorithms, by the way. Like Bitcoin famously uses SHA-256, while Ethereum uses something called ETH. But the core principle of signing with a private key and addressing with a public key is pretty central.
Okay, so the transaction is digitally signed, secured with keys, broadcast out there. But how does it actually get, officially added to that permanent chain of blocks we talked about earlier?
Right.
Who does the heavy lifting to say, yep, this is valid, and lock it into the chain? That's where these miners come in, isn't it?
Miners are absolutely crucial. They are, in a way, the auditors and record keepers of the blockchain network.
Okay.
So, for a block containing a bunch of these signed transactions to be officially validated and added to the blockchain, miners have to compete.
Compete how?
They compete to solve an incredibly complex mathematical puzzle. It's designed to be very difficult and requires significant computing power. This whole process is generally known as proof of work.
Proof of work. Okay. Sounds intense.
It is. The first miner to successfully solve that puzzle gets the right, essentially, to add the new block of validated transactions to the official blockchain.
And they get something for that, right? It's not just for fun.
Definitely not just for fun.
Yeah.
For their effort in securing the network and validating transactions, which takes a lot of electricity and computing power, they're rewarded. For Bitcoin, the current reward is 12.5 Bitcoins for adding a block.
Ah, okay.
This entire pretty energy-intensive process of solving the puzzle and adding the block, that's what we call mining.
So mining is the process of adding a block.
Yes. And once that miner successfully adds their block, the information is instantly broadcast across the entire network. Everyone updates their copy of the ledger, and the relevant wallets like Phil's and Jack's in our example are updated to reflect the transaction.
That's a really intricate system, a true marvel of cryptographic engineering when you lay it out like that.
It really is.
But okay, let's shift gears a bit. We've covered the theory, the mechanics. Let's talk about something tangible, a real-world application that really shows blockchain's practical value beyond just, sending crypto between friends.
Good idea.
Our sources offer a fantastic example with a huge company, Walmart.
Yes, the Walmart case study. It's a great one because it highlights blockchain beyond finance. Walmart faced a really significant and costly challenge.
What was that?
They were experiencing high return rates and giving out a lot of refunds, especially for things like fresh produce, because of poor product quality reaching the shelves.
Okay, spoilage and damage happens.
Right, but the biggest headache for them was their inability to quickly figure out where the problem originated. Their supply chain is incredibly complex. It's global.
Yeah, I can imagine.
It stretches all the way from the farm through storage facilities, various transportation hubs, processing centers, distribution centers, and finally to the customer's hands. Trying to pinpoint the exact point of failure in that massive chain was, well, it was like finding a needle in a haystack. A huge black box in terms of accountability.
That sounds like an absolute nightmare for logistics and quality control, especially at their scale. So what was it about blockchain, specifically its architecture, that made it the right tool here? Why not just a better database?
That's the key question. What Walmart really leveraged was blockchain's unique ability to create a single, verifiable, shared source of truth across that incredibly complex, multi-party supply chain.
Okay, a single source of truth.
Exactly. Instead of having all these different companies and departments using their own separate siloed databases, which might not talk to each other or trust each other, Walmart adopted blockchain. They used it to permanently inscribe data about the quality and the journey of the goods at each critical step onto an immutable ledger.
So data gets added at the farm, then at the transporter, then at the warehouse?
Precisely. Each step leaves a cryptographic trace on the blockchain. So now when a customer flags a product as damaged or if there's a recall, Walmart can, reportedly in mere seconds, trace that specific product back through the entire supply chain on the blockchain. They can correctly identify exactly where in the chain the damage likely occurred. Was it during transport between point A and B? Did it sit too long in a particular distribution center?
So no more guessing games or finger pointing.
Exactly. It eliminates the blame game because the record is immutable and shared. It allows for immediate, targeted intervention. They can identify and fix problem areas, hold specific partners accountable, and ultimately enhance their efficiency and product quality. It provides a level of transparency and trustless verification that traditional databases just couldn't offer across so many different players.
That's a powerful illustration of blockchain moving beyond just finance into something like supply chain management. Really shows its versatility.
It absolutely does.
So, okay, wrapping this all together, what does this mean for us, for you listening? At its core, what have we learned blockchain really is? It seems to be fundamentally a collection of records linked together, almost impossible to alter once they're there, all protected by some serious cryptography.
That's a great summary.
And the result is the system that offers incredible transparency, security, and potentially a lot more efficiency to any system that decides to adopt it.
And if we connect this back to the very beginning, back to the why, it's clear how blockchain offers a really robust alternative to many traditional systems.
Right, the ones with those single points of failure or trust issues.
Exactly. It's built on this foundation of distributed truth, of verifiable information. It creates a whole new paradigm for how we can manage and secure data, shifting away from relying on centralized trust towards a system where trust is kind of inherent in the network itself, baked into the math.
Which leaves us with a really interesting thought, something for you to consider as we wrap up this deep dive. How might these core principles of blockchain reflect Things like distributed trust, verifiable records, immutability, how might they reshape other industries? Or even other aspects of our daily lives. We've talked money, we've talked supply chains. But where else could these immutable, transparent ledgers provide immense value? Perhaps in areas we haven't even fully explored or imagined yet.
Yeah, that's the big question, isn't it? Where else can this go?
Something to mull over. Thanks for joining us on this deep dive.